Hey, today we're going to be dealing with inverses of, or an inverse of a function, and how to sketch the inverse of the function is kind of that's our essential question here. What you're going to do is, with your groupies on page 148 of your student journal, I want you to complete those problems. Now you need a graphing calculator to do that. Okay, off you go. Hey, here we go. If you take a look at the graphs here are the different graphs I have, and I've highlighted a few points. So the first graph there, the first two functions you're supposed to graph, got them right there. And then you have your second two functions, third two functions. Obviously, it may be different viewing windows in the fourth two functions. Pretty. Okay, so what'd you guys find out? They intersect where? Okay, they always cross at a single coordinate. Yeah. When they're congruent, so symmetrical? No? Okay. So what's it called when, let me have this line right here. Okay? And if you notice on that line, I'll try to make it so you can see both. What do we call that? It's a line of, okay, also known as, in this case, a line of, someone said it over there. It's a line of reflection. Okay? Now you'll note that this line right here that I've drawn is the same line as this line right here. Okay? What is that line called? Okay, we know it's a line of reflection. What is the actual name or equation of that line?
Y equals X.
Y equals X. Okay, so these are inverse functions. Pay attention, please. These are inverse functions, and each one of those functions are reflected over the line y equals x. All right? It's a key piece we want to write down. Another key piece, if you just spend some time focusing on this first one here. Actually, before we do that, look at your neighbor's paper, see if they wrote it down. If they didn't, ask them what's wrong with them right now. They need to write that down, man. All right. Hey, now time's up. You're done asking what's wrong. Hey, guys, seriously, it seems like a very easy concept. However, a bunch of easy stuff, once put into a bowl, becomes more difficult to deal with. Okay? And that's called your test. And then you have a lot of that stuff in, and you have a final exam, and then you have next year when you want to reference it. Make sure you have it in your notes. Okay? Hey, this point right here, 0, 3, is reflected across the line of reflection and hits that point right there. Now remember, properties of reflection, they cross the line of reflection at a right angle, they're equidistant away, so therefore I know that that is reflected to that. What do you notice about those coordinates? And the same thing down here. Talk to your neighbor real quick. That is -5, -2, and -2, -5. Okay? What do you guys think? Chase? Yeah, the y equals the x, and the x equals the y. Crazy, right? The x and y switch. Okay? The x becomes y and the y becomes x. They just switch positions when you have inverses. So when you're looking at coordinates, you could just change the coordinates and you'd know where to plot the other one on another graph. Or if you're looking at an equation, for instance, you could just switch the values in your equation. So if I went back to this equation right here for part A, this says, really, y equals 4x plus 3. That's when we say f of x is the same thing as y. And this says y equals x minus 3 over 4. Now looking at those may not look like inverses, but we know they are. We've graphed them. We've defined inverses. And then if I take this second equation, I say, well, McCoy said I could just switch x and y values. So y is now x is now y. And if I solve for y, let's go ahead and solve for y. We'd have multiply by 4 and add 3. Okay? You'd have that equation. Now, wait, dude. Check it out. When I switched it, it's the same as that, right? Okay, that, you guys, because they're inverses. All right, so if you were to switch the x and y values in what you say is its inverse, and then solve for y, you better get the same equation, because they're inverses. All right? Okay, very good. So, let's go ahead and take a look at the next page. Yes, what's your question? Okay, that has nothing to do with this. Here we go. All right. We're on page 149. All you need to know, Chase, is that you're not at lunch right now. Okay. Unless you're like that student last period that had a dream about math class, which I was very impressed with. I was very happy about. Okay? And you're living in a dream right now, asking that question. But you'll wake up here in a minute. All right. Here we go. Page 149. Here we go. Check it out. Hey, remember the graphs are reflections in the line y equals x. So what you could do is just pick a couple points and switch the coordinates and replot them. Okay, so we could pick those coordinates. Okay, that's -2, -6, and make it -6, -2, which is right there. Or -2, 0 would be 0, -2. Okay, so when you're graphing, just reflecting the y equals x, or just switch the x and y values, and those are your new coordinates. That's actually the answer to number 3 there. All right. Number kind of talked about already, but you can look at it later if you'd like. Any questions? Okay. So what I'd like you to do is turn to page 151 of your student journal. 151. Just so you know, page 151 is going to be your assignment tonight. Okay? I would like to go through problem number 1 with you on page 151 and start on number 4 with you. So, let's go ahead and take a look at number 1. Read the directions to yourself, please. Okay, so a lot of times you're like, huh? So solve for y equals f of x. What does that mean? It means make f of x be, just call f of x y. That's what that says. Okay? Solve y equals f of x for x. All right? So that means make f of x y, and now solve for x, meaning get x by itself. Add 1. And then divide by 2. Now you could leave it as y plus 1 over 2 equals x. Oops, not equals y, equals x. Or you could change it if you want. You could call that y over 2 plus 1/2 equals x. Either one would be fine. Okay? Okay. Yeah, we haven't got there yet, dude. You're like jumping ahead. Okay? So one of the pieces they've asked us to do is this. The other part is what Kai was so excited to get to. That when the output is -6. So what is our output, x or y? Y is your output. That's why I was using those terms today. Y is your output. That means solve for your input. Find x when y is -6. That's why we solve for x. So we put -6 in for y. Add 1, divide it by 2. You end up with -5/2. X equals -5/2 when y equals -6. By the way, you guys know that that's a coordinate on a graph somewhere, right? Let's not lose sight of that. That's what you actually found. You found a coordinate on a graph. Maybe there's money there, buried. You never know. All right. X marks the spot. All right. Any questions? Hey, number 4. Take a look at number 4. Find the inverses of the function, then graph the function. So, you guys remember inverses, all we have to do, well, first I'd probably rewrite it as y equals, just because f of x is so cumbersome. Okay, so y equals 10x. That's one of my functions. Let's call that, let's say that's y sub 1. If I want to find the inverse of that, tell your neighbor what you need to do. Okay, volunteer, what do I need to do? Yeah. Yeah, you can solve for x. X equals, so if I rewrite that function here, y equals 10x. Okay, and I solve for x, I get y over 10 equals x. Or another way of thinking that is 1/10 of y equals x. Well, that's the inverse function, right? No, that's still this function. Yeah, you have to now switch x and y, right? Remember, the inverse function switches x and y. So we've got to now call this 1/10 of x, so that's called transposing them. Okay, you're transposing x and y. That is the inverse function, so we'll call that y sub 2. When do you switch x and y? Well, you could do it at the end, or you can do it at the beginning if you want. You could have started the process by going, okay, I'm just going to switch x and y and solve for y. Yeah. Nope. Question? Yeah, that's the other way you could have done it. You could have graphed the original function, reflected it, and then wrote the equation. But you guys, when you're finding the inverse function, you must, at some point, switch your x and y values from your original function. I usually do it at the beginning, and then, so I would usually just rewrite this to begin with as x equals 10y, and then solve for y. The textbook, this textbook that you're using right now, goes this route. It switches x, or it solves for x, and then it switches them. Okay? How many think you got that? Okay, last piece. Okay, and then, by the way, you graph it. I'm assuming you can graph them. Yeah. Last piece, number 7. Determine whether each pair of functions, f and g, so this and this, are inverses. Tell your neighbor how you know a function is an inverse of another. The points are not opposites. They're switched. They're transposed. So -4 and 17, did they switch? Did they switch here? Did they switch here? Did they switch here? Are these inverses?
No.
Wait, no. Why? Oh, yeah. At the very end, they try to fool you. Unbelievable. Those aren't the same. No, they're not. Because that last one has that -1. Make sure you explain why.
Oh, it doesn't matter.
Hold on, is yours the same?
No. Ours changes a little bit, and it doesn't have G written right there, but...
Your books are different than my book? That's lame-o.
It's still
All right,
no.
hold on. Okay, there it is. It's still no, though. Maggie fixed it up. Well done. And just so Haley gets credit, Haley did. Good job, Haley. Well done. All right. Hey, page 151 is your assignment. Woohoo!